presentation, and let me start. So as Fernando already said, it's about nearly zero energy buildings, and we put a special focus on off-site renewables. The presentation is based on a paper that also has been published by Leonardo Energy, and so you also have the opportunity to read the full paper apart from having a look at the presentation. So this is an overview. In principle, Fernando already told you, and so I will go to the next slide. So what's the issue? Why are we talking about nearly zero energy buildings? Recently, we had an emissions gap report in the climate summit in Cancun, and several scenarios have been presented that give the world a chance to stay below the 2 degrees Celsius increase of temperature limits that many states follow. These two scenarios that you see here, they have a likely chance and a medium chance to achieve this target, but both of them have something in common. It's important that the world greenhouse gas emissions peak before the year 2020, and the world greenhouse gas emissions in 2050 should be 50 to 60% below 1990 levels. And of course, buildings have a very high role in these targets, in achieving these targets. And because Europe is one of the most industrialized regions in the world, Europe has set currently non-binding but intended emission targets reductions of 80 to 95%, which is obviously clearly above these 50 to 60% I just mentioned, but this is because Europe has much more emissions than the average of the world. Maybe some of you know the roadmap for moving to a low-carbon economy. In 2050, that was published by the European Commission in 2011. It gives several non-binding targets, but it gives you an idea about the reduction levels we are talking about. So minimum reductions compared to 1990, you see here. In a cross-sectoral view, you all know the 2020 by 2020 targets. And you see here that greenhouse gas emissions of minus 20% are binding. And until 2050, the EC target is even minus 80%. And we have also more specific targets for sectors. For example, for the power sector, we have a minimum non-binding target of minus 54% in 2030. And minus 93% by 2050. For buildings, we have also very ambitious minimum targets of minus 37% by 2030 and minus 80% by 2050. So you see that business usual action probably won't lead to these reduction targets, especially when we go to the next slide, where the upper limits of potential reductions are mentioned, and you see that the columns even grow somewhat. Yeah, for the power sector, you see a target which is equivalent to a reduction compared to 1990 of even 99%, and for the buildings sector of minus 91%. So obviously something has to be done about this. And one of the major pillars of the European policy is the introduction of the so-called nearly zero energy buildings, which currently has the very nice abbreviation nZEB. So when I'm talking about nZEB, you know that I'm talking about nearly zero energy buildings. The European Energy Performance of Buildings Directive in Article 9 gives a concrete definition on what a nearly zero energy building is. The definition is a nearly zero energy building is a building that has a very high energy performance, and the nearly zero or very low amount of energy required should, to a very significant extent, be covered by energy from renewable sources, including renewable energy produced on-site or nearby. You can see several words or phrases marked bold here in this definition, and I will focus on each of these bold parts later in the presentation. So what you can see is that the question is, when do we have to achieve these nearly zero energy buildings? And this is also something Fernando already mentioned in his introduction when he said that for public buildings we have to reach this level by 2019 already. And for all the rest of new buildings, we have to reach the nearly zero energy buildings level by 2021. So when you have a look at the level we have today, or even at the building stock, this is quite an immense jump from what we experience today, what we see today, what is constructed today, to the standards that we have to have in Europe, in every single country by 2019 or 2021 respectively, because the Energy Performance of Buildings Directive gives the framework for national building codes, which have to implement the nearly zero energy building according to local climate and building culture circumstances. But anyway, the nearly zero energy target has to be implemented by every European Union member state. That's why this topic is so important. So one of the specifics of the report we wrote and this presentation is that usually when we talk about nearly zero energy buildings, it is a combination of very high energy demand, or very, sorry, of course, not very high energy demand, but very high energy performance, which is equivalent to nearly zero or very low amount of energy. But at the same time, it is combined with a very significant amount of renewable energy. And usually the notion is that this renewable energy is very close to the building, on site or even on the roof, when we think about PV, for example, photovoltaics, or it should be nearby. That's why I put the sun here, directly to the building. So obviously you can imagine also other possibilities to supply a building with renewable energy, and this will also be one of the major topics of the following slides. So when we discuss nearly zero energy buildings today with the European Commission and with the member states, there are several burning questions in the context of the very low energy demand and supplying these buildings with renewable energy. I tried to summarize these burning questions here on the slide, and one of the major questions is, so is it really a very prescribed building format where designers, for example, don't have the freedom to really design a building, or do all buildings look the same afterwards? So what options do we have to achieve nearly zero energy buildings, not only from building design, obviously, but also from the perspective of supplying the building with energy? Are we very restricted here relative to nearly zero energy buildings, or do we have still quite some options left? So as I mentioned, usually on-site renewables is very much in the focus of the discussion. So the question is, what about off-site renewables? So are they also an option to achieve the nearly zero energy building standard? Because as I said, the definition requires that a very significant extent of the very low energy demand should be covered by energy from renewable sources. And finally, we are not only talking about off-site renewables, but more specifically, what are the options relative to off-site electricity? So what role can off-site electricity play in nearly zero energy buildings? And this would mean that we do not only think about having photovoltaics, which is usually the first discussed topic on the roof of a building, but it could also be off-site PV, for example, which then via the grid is connected to the building. But we of course also can think about wind energy, which usually is not really on the building roof or nearby, but is in quite some distance from the building, feeding the electricity into the grid. So the typical aspects of nearly zero energy buildings are summarized again on this slide. It's very important to see that we are not only talking about residential buildings, but that we are talking about residential and non-residential buildings. We are talking about all new buildings that will be built from 2019 or 2021 on. And when we talk about the services which are included, we are talking about the services in the case of commercial buildings and auxiliary energy, which is used to drive all the previously mentioned systems. Not included are plug loads and appliances. The logic of the European Performance of Buildings Directive is to first reduce energy needs for the services I just mentioned up to a level of cost optimality. And second, the small rest should be to a very significant extent covered by renewable sources. In order to give you an idea what this means in annual greenhouse gas emissions by 2050, we are talking about reducing the CO2 emissions per square meter for the building stock we will have in 2050. So this means the buildings we already have today plus the buildings we will build until then of on average 3 kilograms CO2 or greenhouse gas emissions per square meter in year. So currently we have like a factor 10, like 30 kilogram CO2 per square meter in year. So as this also includes the building stock, it literally means that nearly zero energy buildings also mean nearly zero emission buildings, because the emission reductions that we can achieve in the building stock are limited for several reasons, for costs and for constructive reasons. And so every building we add, in principle, is not really allowed to add a significant amount of emissions to let us achieve the very ambitious 2050 targets. So of course, all the definitions that I just mentioned, they are quite open. Of course, this is the case when you write a guideline or a directive that is valid for 27 EU member states. So you do not want to go too specific. But currently we are really in the stage of how more specific definitions on the European scale, but also on national scale, can look like when we talk about nearly zero energy buildings. And this presentation is one of the bricks to go into this direction. So which reasons would we have to focus on electricity in nearly zero energy buildings? First of all, when you have a look at the total energy consumption, including plug loads and appliances in a nearly zero energy building, so a building that has a very low energy demand for heating, cooling, and ventilation and lighting, you will see that these plug loads and appliances cause costs and environmental impact, which is almost and sometimes even more or higher than what we have with the EPBD services like ventilation, heating. So it is very important to also have a look at electricity to avoid sub-optimization of the total building cost and environmental impact. What we also see is an ongoing integration of power and heat markets. Probably most of you also noticed that heat pumps get more and more attractive in new buildings. For example, in Germany, in single-family homes, they have the majority of installations, so more than gas boilers, for example. We talk about decreasing thermal loads more and more, but due to the ongoing electrification, computer equipment and things like that, we observe an increasing electricity load in the buildings. Another reason to focus on electricity is that buildings are more and more seen as a means for steering load management and for exploiting load management potential. We have more and more small-scale CHPs. Sometimes they are called electricity generating heating systems. We also have discussions about power to gas and also power to district heat, which is also an indirect application of electricity for heating. And finally, what we have seen in one of the previous slides, we discuss very steep emissions reductions in the power sector, which of course makes electricity a more attractive supply solution also for buildings and also for nearly zero energy buildings. So what definitions do we see relative to renewable energy supply in the context of nearly zero energy buildings? So the EPBD itself gives a definition for renewable energy, or better to say for energy from renewable sources. So the following sources are explicitly mentioned. It's wind, solar, geothermal. Then we have hydrothermal, hydropower, biomass, landfill gas, sewage treatment plant gas, and biogases. So in the following, I will mainly focus on wind and solar because it's also related very much to metering schemes around nearly zero energy buildings that could increase the share of renewables. So when talking about renewable energy sources, we have to think about the physical boundaries that we take into consideration. So first of all, we have on-site renewables, and you can see this is directly included in the definition that I already gave to you, but now we have a closer look at this definition and what it means. Then we have nearby renewables that also could be applied and which are also explicitly mentioned in the definition of nearly zero energy buildings in the EPBD. And finally, we have off-site renewables, and those are not explicitly mentioned in the EPBD. And so the question is, are they included or not, the off-site renewables? That's the question. And when you have a look at the definition, we go through it again. It says the nearly zero or very low amount of energy required should be covered to a very significant extent by energy from renewable sources, including, but it doesn't say being limited to or just being energy from renewable sources. It just says including energy from renewable sources produced on-site or nearby. So this means in our thinking that obviously also off-site renewables could be used to supply renewable energy, but that the focal point in the current discussion and in the EPBD are on-site and nearby renewables. But there are some very strong arguments to also include off-site renewables. It's about providing sufficient number of choices for every building owner, because you can imagine not everybody will be able to install on-site renewables or even use nearby renewable sources. And this is also about ensuring equal chances to achieve the level of nearly zero energy building, and it's also to reflect the reality of renewable energy supply, which has higher and higher shares of renewable electricity. So it means we are convinced that off-site renewables must be a part of the renewable energy supply, and specifically also off-site electricity should be a part of nearly zero energy buildings options. So this is a more specific differentiation between the different supply options. So the closest boundary that you can draw is the building footprint. So this literally means that you install some kind of renewable sources on your building. A bit further is the on-site option. That would be supply option 2, which also allows you to generate energy on the cadastre of your building. Then we have the off-site and nearby solutions, and you can also divide them into the supply option 3, which is off-site renewables, but where the building owner also owns shares in the off-site renewable generation capacity. For example, shares in wind farms or remote wind turbines or solar farms. Then the fourth option, supply option 4, would be the case where you simply supply your building with off-site generated electricity in a standard delivery contract which guarantees you that you have a certain share of renewable energy, for example, certified. And going from left to right, you see that the number of options increases, and this also increases the probability of the availability or even the feasibility and ensuring the high share of renewable energy, which is required by the Energy Performance of Buildings Directive's definition for nearly zero energy buildings. And looking ahead, this way of defining it also enables plus energy buildings, and it also enables plus energy buildings not only for the services which are today mentioned in the EPBD, which I mentioned, ventilation, heating, cooling, lighting, auxiliary energy, but also to cover other services like, for example, electricity you need for your elevator or for appliances and plug loads. Again, this picture in another perspective. Usually when you follow the discussion, it's about single buildings and off-site supply. But the balancing gets a bit complicated when you say, okay, or let's start differently. The balance is quite easy when you say, okay, we have this boundary on-site and also the generation is on-site. It's also easy when you say, okay, we have a larger area with a couple of buildings, and within this area we also have the renewable energy generators. Then you could say, let's increase the area further to some kilometers or even to a country, and then you say, okay, we have all of the buildings in a country, and within this country we have, for example, the renewable energy generation. So in this case, we have the same boundaries for the demand side, for the buildings who use the energy, and also for the generation. But the discussion we usually have today is that we talk about a single building, an on-site building, and now how do we deal with the opportunity to only supply this on-site building, this single building, with off-site energy. Yeah, this is the typical situation that is discussed, because then you have two different boundaries. One is around the building or the building site, and the second is some larger circle for where the off-site generation comes from. And in these cases, you even might have still some energy generated here locally from renewables, but you will always usually have the situation that you export some of the energy that is produced within the circle, but you also will import energy which will, for example, stem from the electricity grid and is not only from renewables today, obviously, but also includes conventional energy generation. And so somehow you have to balance what happens within this circle with what happens in the bigger circle and the imports and exports that happen between these two boundaries. The balancing gets easier when you focus from the building owner building, but I'm balancing, so to say, what the owner is doing. So in this case, you can easily have the owner who runs the building and the owner who, for example, owns shares which are not on site, but somewhere beyond on site, but the owner can then balance his building with the shares and the renewable energy generation that he finances outside of the circle. So what about typical sizes of solar, wind, and on-site, nearby, and off-site generation? In wind, when we talk about small-scale wind, this means on-site and nearby. This is usually something around 2.5 kilowatt. When we talk about a community scale, this could be on-site or off-site. This is like smaller of 20 megawatt. And when we talk about utility scale, which is only valid for off-site renewable production, this would be larger than 20 megawatt. We have similar limits defined for solar PV, Again, we have small residential systems which are relevant for on-site generation, larger sizes for on-site generation in commercial buildings, and then we have a size which might be applicable to on-site and nearby, but also to off-site generation. And then we have, again, utility scale plants which are much bigger in size, larger than 1 megawatt, which is relevant for off-site generation. Just to give you an idea about the size of these facilities. A specific discussion point is about the metric that we use for the definition of nearly zero energy buildings, and also the period of the balance. So a typical metric obviously is something like kilowatt hours per square meter in year, but then the question is, are we talking about delivered energy? Are we talking about primary energy? Or do we even talk about CO2? So the EPBD requires to include a numerical indicator for the energy performance and explicitly requires primary energy. So what is usually done today is that the delivered energy of a building is calculated, it's multiplied by primary energy factors, and so you have the primary energy as the resulting performance indicator. The problem with primary energy factors is that sometimes they are quite intransparent. Sometimes they are a bit politically distorted and not really totally reflecting the technical system behind. And on the other hand, we also see, and it is also predicted, a very steep decline in electricity primary energy factors. And because I said at the start, on European level, we have very ambitious targets for carbon emissions, but not really explicit targets for primary energy. It might happen in the future, in the midterm future, that we see a switch from primary energy to CO2 as the primary metric. The period of the balance, the EPBD requires that the balance has to cover 1 year, and in fact, the EPBD is talking about a net balance over 1 year. So it means we talk about heating and cooling for a whole season. This is also the reason why the EPBD requires a whole year, because in some countries we see energy requirement for heating and for cooling. So you really need to have a look at the whole year in order to not lose some of the energy services and the energy related to it. The question is about, okay, we have a balance for 1 year, but we could do smaller sub-intervals and adding them up. And also for these sub-intervals, you could require that the balance is 0 or close to 0. And when we think about electricity grids, the aim of looking at shorter balances obviously is that we create less stress for electricity grids. I will give you an example on the next slide. It is reflected in the so-called load match index. So still assume we have a period of 1 year where we would like to make a balance of energy demand and energy supply of the building. And the case is that we have a building that has exactly the amount of photovoltaics on the roof that delivers on an annual basis the energy which is required by heating, cooling, ventilation, and lighting. So this is meant with the sizing of the system. So it's exactly sized for a net annual balance of 0. Okay, you see this is the load match index of 1. So 100% of the annual consumption of the building are covered. But when you really have a closer look at how much of the time of a shorter period can the building really live without importing energy from the grid, you see that the shorter the time intervals get, the less a building can live with its on-site production. So very easy example, when you think about hourly balances and you have PV on the roof, obviously your building cannot survive during nighttime, which means that finally doing an hourly balancing without taking into consideration storage systems, only 25% of all the year's hours your building could live on the on-site produced electricity. So, of course, even before the European Performance of Buildings Directive had its definition on these energy buildings, we had similar definitions on very low energy buildings, which already dealt with how renewable energy, or from which boundaries renewable energy could be taken into consideration in the building's balance. So in one large project, 71 definitions of something that you could call nearly zero energy building were analyzed. And we had a look at which boundary is explicitly allowed or forbidden or not mentioned in these definitions. So you can see in 60 of these 71 definitions, renewable energy production from the building's footprint was allowed. In 55 of these definitions, on-site generation was allowed. And yeah, we can call it at least, or it's not bad, or maybe only even. 9 of these definitions explicitly allowed off-site green electricity. And others explicitly, and the majority of these definitions explicitly forbids the use of off-site electricity in these definitions. But this was before the EPBD definition was published, and you see that there are still some cases which obviously think that off-site green electricity is a viable option also for nearly zero energy buildings, which is a good starting point for the discussion we have at the moment. So then we have some key issues around off-site renewables. So when talking about increasing the share of renewable energy, the levelized cost of electricity from renewable sources is very important. So the moment these levelized cost of electricity, which means the lifetime costs for electricity generation from renewable sources or also from conventional sources, is calculated in euro per kilowatt hours. And what you see here is for 2010, 2015, and 2020, the predictions of what the cost from different sources for electricity production from renewables, so residential PV, commercial PV, industrial PV, and onshore wind, will be. So today you see the most expensive generation for on-site supply is residential PV. This is somewhere between 20 and 35 cents in Europe, depending where you are, of course. In a sunny region, it will be cheaper. In a cloudy region, it will be more expensive to produce 1 kilowatt hour. And in 2015, you see that quite some price decrease is forecasted. And for 2020, even higher decrease in prices is forecasted. The cheapest version here is onshore wind, which we have just seen is one of the off-site supply options. So we put it also in this picture in order to see the difference. So grid parity for wind and solar is predicted to occur between 2015 and 2020. Sorry, this is a mistake here. And obviously, the more wind and solar reach grid parity, which means the price of producing electricity from renewable energy is approximately the same than what you have to pay for electricity, the more attractive, obviously, these options get. So I put the predictions for the retail prices for industry consumers here. You can see that, for example, already today, where's the arrow? Already today, this is the range of the prices for retail industrial consumers. And you see that generation from onshore wind currently has approximately already reached the level of the price industry has to pay for electricity. So it means for them it's already a viable option to go for off-site supply from onshore wind, but for all the others, like industrial PV, utility PV, they are still much more expensive than what industry has to pay. If we continue, you see this is the range for commercial consumers, and this is the range for residential consumers. So the more you have to pay for electricity, the more options you have which are attractive to instead get your electricity and also electricity for your renewable, for your nearly zero energy building from renewable sources. Yeah, that's clear. I hope that the lower the price for electricity from renewables, the more attractive it is to replace your standard supply by electricity from renewables. So the next important topic is metering schemes. So when you want to supply your renewable, your nearly zero energy building with renewables, the metering scheme also has to reflect this. So what we have seen is something that we call net metering. So that means as long as you buy energy from the grid, your electricity meter turns forward, but the moment you produce electricity on site, it turns backward again. So at the end of the billing period, you will just pay the net amount of energy between what you got from the grid and what you fed into the grid. So there are some potential limitations. It might happen that you get different rewards for the energy you produce depending on if it is from PV or wind turbines. There also might be capacity limits. For example, you are only allowed to feed in 5,000 kilowatt hours per year, or you are not allowed to exceed 5 kilowatt peak, for example. But the new developments of smart meters in principle can handle all these cases so that it's also possible to allow for different tariffs for imported and exported energy. So the variations of all these previous parameters obviously determine the attractiveness of on-site generation, and at the same time then to think about if it's maybe more attractive to have off-site generation. So when we have a summary of the financial viability of net metering schemes, assuming a 2020 situation, we have a look at the retail price grid parity. So we say, okay, producing electricity from renewable sources will have the same price as what you have to pay for electricity from the grid. So assuming the situation where production is smaller than consumption, getting the retail price for what you feed in is obviously a very attractive situation. So when you only would get the wholesale price, which excludes fees for the grid, for example, also excluding taxes, it really depends how big your system is. So as long as you have a small system, you see the yellow part of this curve is what you can self-consume. This here is what you self-generate. And obviously the surplus is fed into the grid. So if you have a very big system, you have a very high surplus, so everything what is gray here would be fed into the grid. That would mean you have a very much oversized system. As long as you get the retail price for what you feed into the grid, this is a very good situation, obviously. But if you only get the wholesale price, you won't have the possibility to refinance the very big investment you had for this system. So it also very much depends on the metering scheme and the fee you get for feeding in your electricity, how attractive it is to provide your nearly zero energy building with a significant extent of electricity from renewables. So there are also off-site generation schemes. We had seen the options 3 and 4 before, which were summarized as off-site renewables. First of all, we have ownership schemes where the building owner invests in production capacity. And on the other hand, we have this option 4 that we've seen before, where you only simply have a delivery contract and just buy your electricity from maybe even a cooperative or usually from a utility. So these are the two options you have. Again, a flashback to the supply option 3. You remember off-site renewable, where the building owner has shares in renewable energy generation, and the option 4, where he simply buys energy from the grid without having shares in the renewable generation. So having a look at the ownership share scheme, it works like that. The renewable electricity generator is installed before the meter. It means it's beyond the on-site boundary. And usually, in this case, we have a focus on wind and not on PV systems. So we have two possibilities for the building owner. He has an ownership share. This is the community system. And the second option is the delivery contract. So the cooperative system works as follows. A group of people becomes member of a cooperative and owns a renewable energy facility, for example, a wind park. The power which is generated in the wind park reduces the electricity bill for the one who owns a share in this facility. You can also think about buying this share from a bank or a broker, but again, it would reduce your electricity bill. Experience with such system exists in Denmark, the Netherlands, and Germany, for example. So usually you would think that probably the physical proximity to the building is necessary. But for example, Denmark started out with requiring that the wind park has to be very close to the building in 3 kilometers distance. But then step by step they expanded to the area of the entire European Union, which is somewhat larger than a 3-kilometer circle. There are projects which exist with and without government exports, so everything seems to be possible. And usually there is a standard taxation model. As long as the generation that you get from your share does not exceed what you consume over 1 year, you get a tax discount. And the excess generation, so everything that goes beyond what you use in your own home, is considered as a business case and usually has higher taxation in this case. As an example, in the Netherlands, 10 to 15% of the overall installed wind capacity are based on this cooperative renewable scheme, which is quite significant. Okay. So then we have an issue with the EPBD-related CN standardization. So there is a set of 31 European standards, so-called CN standards, which are the EPBD's backbone. Currently, these standards are being updated, and they should be ready by 2014. So the member states do not have to necessarily apply these European standards in the calculation of the nearly zero energy buildings, but the EPBD says that the methodology for calculating the energy performance of buildings should take into account European standards. And we have discussed in this webinar quite some time on the importance of boundaries. Do we have on-site, nearby or off-site generation taking into consideration of the nearly zero energy balance? And this is exactly what is defined in the European norm 15603. It's a so-called umbrella document. So what they are currently doing is they assess the boundaries, and in this document they are defined as so-called geographical perimeters, and this is exactly what we've discussed before. And the good news is what is currently discussed in this committee dealing with this norm is that they define different geographical parameters. The first one being the conditioned space within the building. The second one, the building site, so what we just have seen as on-site. Third, outside the building site, nearby, and outside the building site, distant. What is good is that currently it is not yet discussed or decided how distant generation will take part in the nearly zero energy buildings balance, but the committee dealing with this seems to be very open to also take into consideration off-site renewable generation. What is also under discussion is the different primary energy factors that you could imagine for import and export of electricity. So when we have all these schemes, it's of course very important that they are monitored, verified, and enforced. So we need very clearly defined indicators. So what exactly means an energy neutral building or a nearly zero energy building? it would also be very helpful if energy performance certificates would show the nearly zero energy building status. So for example, currently none of the energy performance certificates that I'm aware of show you the renewable share. There also should be a clear accounting of energy from renewable sources. And currently, of course, only for the services which are included in the EPBD, but in the near future, maybe they also could include appliances and so on. Currently, on-site generation has the highest probability of having a persistent renewable energy share. This is one of the final major aspects that I would like to mention here. When talking about providing renewable electricity to a nearly zero energy building, of course you would like to avoid that you get a certificate and then you change the supplier of electricity, which has a much less share of renewable electricity. So this is something, of course, that you would like to avoid. You can imagine that still works quite good when you have a kind of community scheme where the building owner owns a share in a renewable generation facility. In this case, everything is fine, but still when he would sell his share, also the renewable energy share in the building would be sold. So one of the solutions that would be applicable, but where legal constructs currently are not in place everywhere in Europe, is that we find a solution where the renewable energy share doesn't stick with the owner, but the share sticks with the building. And a similar construction also could be imagined for off-site electricity. You get a certificate for a certain renewable energy share in your purchased electricity, but this certificate and this electricity somehow has to be coupled with the building and not with the owner in order to remain a renewable energy, a nearly zero energy building, even if the owner changes. So the conclusions. Nearly zero energy buildings are a cornerstone for the EU 2050 climate targets. Only a combination of demand reduction and renewable energy will lead us to these very ambitious reduction targets. Currently in the discussion, on-site renewable energy is in the focus, but I think I pointed out that off-site renewable energy must also get a viable option for achieving nearly zero energy buildings. For these reasons, equality, even chances, and in order to avoid discrimination. So it's very important that somebody who has to build a nearly zero energy building, which will be mandatory by 2019 or 2021, has a vast set of options to achieve the standard. So I think I'm not going into the details of this one. It simply gives an overview about advantages and disadvantages of the different options that we have just gone through, on-site, off-site, with ownership of shares, and off-site with simple purchasing of electricity. And the recommendations that we can give from the analysis that we have seen is, what we need is that we need standardized products for off-site renewable energy supply for nearly zero energy buildings. So these standardized products are not yet in place, but you have seen that we need products which really ensure the persistence of the renewable energy share, even in case of an off-site energy supply solution. The key terms of the EPBD within the nearly zero energy buildings definition, they still need sharpening because currently they are still quite vague. We need a very clear regulation for how to calculate the renewable energy share. This is quite surprising, but currently there is no real definition on how to do that. Even different experts won't be able to give you a clear answer on that. So it means boundaries have to be very clearly defined, and primary energy and greenhouse gas factors of import and exports have to be defined as well, very clearly. We need an increasing focus on non-EPBD services because, as I pointed out, for example, appliances have also a very high share in the overall energy cost of a nearly zero energy building. And it can't be the target that we do a sub-optimization only for ventilation, heating, and cooling, but for the overall energy consumption of the building, this optimization should be done. What we also need is developing metering schemes suitable for off-site solutions, and we also need to have a focus on the so-called ecologic additionality, so that the renewables that we apply in nearly zero energy buildings really are additional renewables, and they are not just taken by applying a bookkeeping exercise from another sector, for example. So as you see, it's quite a heavy task to realize nearly zero energy buildings by 2019, 2021. And it's quite a heavy task to also allow off-site renewables to play a big role in this building concept. But I think we still have sufficient time to achieve this, but we really have to start acting on this now. Thank you very much for your attention, and now I am looking forward to your questions. Thank you very much.
Okay, thank you very much, Andreas, for this very comprehensive presentation. So you presented the many weak points that still are pending on this directive and this purpose of European Union to go to zero energy buildings. Good. So I think we can go to the Q&A session now. So we now invite the audience to submit their questions. So some of them already submitted. So let's go one by one, and you can type your questions in the Q&A window at any moment. So let me, Andreas, go through the questions. One moment, please. Okay, so there is a first question relative to how to measure, I suppose, monitor the building performance.
Yeah.
If you have any answers on this, Andreas, this is probably a bit early, as we are talking about projects where everything is to be defined, but maybe we already know something on monitoring and verifying. Thank you.
Okay, yeah. As you see, the European Performance of Buildings Directive mainly focuses on calculated values, but when we talk about defining the real share of renewable electricity or renewable energy in the nearly zero energy buildings concept, I think we really have to strengthen the monitoring of the performance of these buildings, which is not really in place in the different European countries right now. So what I can tell or answer on this question is I really would like to see more real field monitoring of the performance of these buildings, but it's not really mandatory implemented in the European Performance of Buildings Directive.
Okay, good, thank you. So we have another question. So for near zero energy buildings, we need renewable energy. Any thoughts or opinion on cutting-edge reductions in consumption for high-rise buildings? Thank you.
Yeah, this is a very nice question. So, yeah, as I said, first of all, these buildings are, of course, also included in the European Performance of Buildings Directive. That's very important because in some cases we are here talking about office buildings and not only just about residential buildings. So they are included and they also have to be nearly zero energy buildings. I mean, in principle, there are already quite some examples for very low energy buildings which, well, maybe do not really apply cutting-edge technology. For example, the KfW building, it's a very big German bank, has a very nice building in Frankfurt erected, which has a very low primary energy consumption and which probably already would qualify for the nearly zero energy building. I mean, what they really do is They apply a very good insulation. They do cooling with very high COPs. They use not air for heating and cooling, but they use like activated ceilings, which also gets down the temperatures. So just in principle, the standard set of low efficiency or very high efficiency measures that you also can apply in other buildings. So they were also very helpful and effective in the case of this high-rise example that I just mentioned. So it's possible to achieve it in high-rise buildings as well.
Okay, good, thank you. There is a question, what's the scope for PV in the future? Let's probably interpret this question as what role do you see for PV in the context of nearly zero energy buildings? Thank you.
Yeah, so I hope I pointed out that today PV plays a very big role in the definition of nearly zero energy buildings, because usually people define it as simply, okay, how much PV do I need on my roof in order to achieve nearly zero energy building standard? So I think we will see a development a bit away from this, so to larger systems where people really buy shares in larger facilities in order to get the prices down. And I think that if we really achieve the possibility to apply off-site electricity in the nearly zero energy buildings concept, wind will partly replace the role PV plays today in future.
Okay, good, thank you. You mentioned 71 definitions collected from 17 countries. Could you please explain how you collected such high number of definitions? Are they official? So maybe you can comment on this. Thank you.
Yes, of course. Yeah, it's good that you asked this question, because I think I was very brief on this point. These definitions were collected in 17 countries, as I said, and they are non-official. Most, in principle, all of them are non-official, because official definitions for nearly zero energy building are just created now with the reports on the improvements relative to nearly zero energy buildings of every member state are sent to Brussels, to the European Commission, and there you have to define as a member state the official version, what you think is a nearly zero energy building. So these were non-official definitions, like, for example, passive house or Minergie in Switzerland, and definitions like that, which were roughly categorized as, okay, this is probably what finally will turn out to be the level of nearly zero energy buildings, and let's have a look at these non-official definitions, how they reached the level that in these cases were thought to be on the level of a nearly zero energy building.
Okay, good, thank you. Is there any formal relationship between near zero energy buildings and passive house concept? Thank you.
So, in fact, there is no formal relationship, but in principle, there is an informal relationship so that you can say that several recent projects have dealt, for example, for the Buildings Performance Institute Europe and also for the European Commission, with doing a lot of simulations and trying to find a solution which insulation level, which HVAC technologies will lead you to something that could be called nearly zero energy buildings. And really the bottom line is that we are very close to passive house standard in all these simulations, and then you have to supply this close to passive house standard building with renewable energy.
Okay, thank you very much. There's another question. Which boundary conditions do you consider in your calculations, for example, according to renewable energy law, etc.? You presented that there are many definitions and things need to be further clarified. Do you have any additional comment on this question? Thank you.
Yeah, I think this is exactly one of the questions that we need to answer, that we get more harmonization in this, because fortunately the EPBD doesn't really prescribe the boundary conditions, and every single member state in the European Union sets his own boundary conditions and also the size of the boundary. So is it on-site, nearby, or off-site? And so currently you really cannot compare, for example, the energy values that are calculated in different member states. Even if you would take the same building, you could get very different results because of these very different boundary conditions. So one solution would be that the member states really strictly apply the European standards, the CEN standards that I mentioned. That would lead to more harmony in what the member states do, and then things would get more comparable.
Good, thank you. Is embodied energy completely disregarded in defining the building? So, well, whether the life cycle assessment view is included, or we are just talking about operational balances. Thank you.
Yeah, of course I understand the question, as when you introduced me, I dealt quite a lot with life cycle assessment in the past. In the EPBD, in the European Performance of Buildings Directive, it is not included yet, and I also think that in the midterm, in the medium term, it also won't be included, but you see, maybe it's interesting for you, there is a report, Principles for Nearly Zero Energy Buildings, that was published by the Buildings Performance Institute Europe like 1 year ago, and there was a strong pledge for also including the embodied energy in future versions of the European Performance of Directive in order to really achieve a life cycle optimum and not a sub-optimum only for a part of the operation stage. So I totally agree. In principle, it should be integrated, but this won't be tomorrow, but maybe the day after tomorrow.
Okay, good. Next question, you spoke a lot about near zero. Okay, let me send it. I'm sorry. Okay. Near zero energy buildings connected with off-site renewables. I'm more interested in technologies to achieve zero energy buildings on site. Do you know technologies or resources, packaging, and well, delivering this? Relative to this question, I recently attended a conference where the program to incentivize battery use in Germany in households to well, accommodate more PV power. So I'm linking with this question to submit also my question whether the role of on-site electricity storage is going to be important. I see that there is a huge trend in Germany today, even with incentives and so on. So could you comment on this? Thank you.
Yes, of course. So obviously we had a focus on electricity in this presentation, and so it's also okay to think about PV on the roof, but when we stick to Germany, of course, there are also other possibilities possible. For example, you could also achieve a nearly zero energy building by simply installing a wood pellet boiler. The problem with this solution is that we do not have enough wood pellets in Germany to have all nearly zero energy buildings running on this technology. So there are also other packages, sometimes ready-made, with PV on the roof. We do not really have wind packages. And honestly, I mean, there are no real nearly zero energy packages today because this is only mandatory from 2019 or 2021 on. So, but probably, yeah, we will really see packages emerging within the next few years where you really get the nearly zero energy building standard in a ready-made package.
Okay, Andreas, for some reason I think your voice became...
Oh, sorry, should I...
Okay, so no, it's better again. Okay.
Could you still hear what I said, or should I repeat it?
Yes, I think we could hear, but the sound level was reduced, but still we could hear you.
Okay.
Okay, good.
Yeah, and as to, sorry, I didn't answer to your storage question. Yeah, you are right. It is really a trend in Germany. But I think currently it's really a push in order to give more speed to the development of storage capacities. So there are quite a lot experts dealing with electricity grids which really see this development a bit critical, and they think that bigger storages should be used because they have much lower costs, and in the end they do not really think in on-site and off-site, but they really see the electricity system as a big copper plate where it doesn't really matter where your generation capacity is installed, and so it could be everywhere, and it doesn't have to be on the roof at all, for example.
I see. That's quite clear. Thank you very much. There's a question basically relative to the use of electricity in buildings to charge electric vehicles or, well, any other interaction with outside elements. Can you comment on this? Thank you.
Yeah, I mean, this is really a question of balancing. I mean, you saw the definition of the energy buildings. I mean, currently it's the demand for heating, ventilation, cooling, and then it's really a balancing exercise which share of the renewable electricity you use for these purposes. So under the current definition, if you would need all, or if you would use all your local renewable electricity supply for an electric car, you probably wouldn't have achieved zero energy buildings because you didn't use this electricity, this renewable electricity, for these EPBD related services, heating, cooling, ventilation, lighting. So for what you say with the electric cars, the boundary would have to be larger in order to also include other energy services like using a car.
Okay, there was also a question relative to efficient appliances. So as far as appliances are excluded, we basically don't care whether they are efficient or not. They are assumed to be regulated by other regulations in course.
Yeah, exactly. Okay. So they are related by the Eco-Design Directive. Yeah.
Okay, good. So let's go to another question. Well, I'm not sure this is clear enough. Let's go ahead. What's the difference between the near zero energy buildings and greenhouse gas protocol principles? I don't know whether there is...
Yeah, I can imagine what the question means. So in the EPBD, we are talking a lot about primary energy and renewable share. But we do not talk at all, which is surprising in the Energy Performance of Buildings Directive, about greenhouse gas emissions. But that's what I said. So for a project that we did for the Buildings Performance Institute, and I mentioned the report already, we try to translate these principles into greenhouse gas emissions. And it turned out that the level of a nearly zero energy building for the whole building stock should be something like 3 kilograms of carbon emissions by 2050 per square meter of the buildings we have in Europe, which is approximately 10% of what we have. So maybe this is quite a good rule of thumb to translate the level of nearly zero energy building currently defined in primary energy terms, usually in terms of greenhouse gas emissions.
Okay, good. Thank you for this explanation. Another question, how do you see the further development of LEED, BREEAM, etc., our certification schemes in the light of the move to the near zero energy buildings?
Yeah, we have dealt with certification schemes in several projects, and there is also DGNB in Germany, for example, which is also similar. And what is the nature of these certificates? That in principle they pay quite small attention or quite a small share of the overall value that you achieve in the rating goes down to the energy performance. So you have lots of...
Sorry, Andreas, you became far again.
you have lots of other criteria in these certificates, and yeah, I don't know. Of course, I would really like to see that the share of energy performance in these certificates increases in the future, but currently, in my opinion, the share of the energy performance of the buildings is too low in these certification schemes that you mentioned here. And yeah, I hope they will increase.
Okay, good. Thank you. A question relative to the potential role of wind energy on site.
Yeah, I mean, if we'll have more attractive small urban wind turbines in the future from energy generation or energy yield point of view, and also from economic point of view, yeah, I'll be happy. So I talk from experience here, because my company Ecofys also tried to develop an urban wind turbine in the past, but yeah, the energy yields were really much lower than what was predicted and what can be achieved with larger systems. So I think that's also one of the reasons why we discussed the opportunities for off-site wind generation and taking this into consideration in the new zero energy, because I think these very small systems will never compete with the large systems.
Good, thank you. Another question. You have mentioned about power to gas concept for buildings. How do you think, which potential has this technology for building applications? I would like as well to ask a question. I also heard about the power to gas concept, let's say on a country level in Germany again, as a means to, well, to get big scale balancing avenues. So do you have some comments on this, well, big scale versus building oriented balancing systems? Thank you.
Yeah, so to be honest, I do not really have a fixed or very well thought through opinion about this. So for example, in Germany currently several projects are running which really try to deal with this complex system of how the heating and or the heat and power market grow together, and yeah, one of the together aspects obviously is the power to gas concept. So we have in Germany, we have a very large gas grid, and obviously it would be a pity to not use it in the future as well, because all the investments would be sunk costs in this case. And I think that the studies that are running at the moment, they really will have a look how much of the power can be converted to gas in order to use the existing systems. So, but yeah, in principle, of course, it also qualifies as long as this is renewable gas from power. But yeah, I really can't tell you at the moment what will be the magnitude of this application in the future.
Okay, thank you. We have another interesting question. So it's about the possibility to compensate net consumption versus net production of buildings, and then get into a near zero balance in a building area, so accounting several buildings as a whole. Is that something considered at the moment? Thank you.
Yeah. This is also one of the points that we have looked at in depth in this study that I have mentioned, and our interim conclusion was that currently the EPBD in principle only focuses on single buildings. So this is the state of the art, and it's not really foreseen in the current version of the EPBD that you balance buildings. And in fact, for the case of new buildings, we think that really every new building should have a very low demand, and that if we really increase the number of options in order to get off-site renewables, probably every single new
Sorry, Andreas, we lost your voice.
Sorry, every single new building could qualify for being a nearly zero energy building. So it's very different in the case of existing buildings when we talk about existing residential areas or districts. So in this case, it is really the case that some of the buildings have much less possibilities to get down with their consumption than other buildings. And for existing areas, I think we really have to develop district solutions where some buildings benefit from the very high performance of other buildings that can go further than others which have restrictions, and where you really also have to take into consideration district supply concepts like a larger CHP plant, for example, that provides a number of buildings with heat and electricity. So this is something that we really see should be in place, maybe also in one of the upcoming versions of the EPBD for existing buildings, although existing buildings relative to nearly zero energy building standard are not yet covered by the EPBD. So member states only have to explain their plans how to increase the number of nearly zero energy buildings also in the building stock, but there are no numbers or percentages the building stock has to achieve relative to nearly zero energy buildings.
Okay, thank you. I have a general question. What's the main rule? Or, well, maybe we can enlarge the question to, well, what's the set of rules in the project conception for new buildings and the ones to be recovered to achieve near zero energy buildings? So, meanwhile, Hans pointed out one resource, so it's in the link indicated on the right window. So do you have any comments on this? Thank you.
Yeah, I think the building renovation is meant with the recovery, right?
Yes.
Okay, so in this case, yeah, as I just pointed out, currently the EPBD only mandates from 19 or 2021 on this standard for new buildings. But yeah, I mean the principles in reality in the field, and we have seen some nearly zero energy buildings in renovation as well in the past. In principle, it's the same two basic concepts. What I mentioned are also the guidelines for the EPBD. First, reduce the consumption as much as possible, and secondly, try to cover the very low energy consumption with renewable energy. So all other concepts, at least today, do not seem to lead to the least possible life cycle cost.
Okay, thank you. So we have other questions. One moment, please. So there is another question relative to wondering what's the best solution for passive house concepts, only with electric appliances and heating ventilation system, based on electricity instead of natural gas, biomass boilers. So whether the electricity has a predominant role in this context, or we can still keep considering natural gas or biomass. Thank you.
Yeah, I understand the question. So I think in the end, by 2050, we will need a mix of all these things that are mentioned here, although, as I pointed out, by 2050, so in the very long run, the greenhouse gas emissions have been on such a low level that natural gas will probably really totally eliminate it from the supply of buildings. So we will probably still use the infrastructure that we have today for gas, but it won't be natural gas anymore, but in this case artificial natural gas made from renewable sources. And the same with biomass. For example, in Germany there is a rough number how much buildings could be supplied with biomass in buildings, and the biomass we have in Germany would not even be sufficient if all the buildings we have in Germany would be on passive house level. And so this is also a hint, and this is also probably valid in other EU countries, that in the end we really need a mix. And yeah, definitely as the greenhouse gas balance of the power system is forecasted to be better and better, the share of electricity in these very low energy buildings will grow in the future steeply.
Okay. Well, relative to biomass, this is probably one of the reasons why the off-site renewables are probably less considered. Well, we will see how this evolves. Thank you.
Yeah.
So let's go for another question. Do you see a competitive role for small hydro in this scheme?
Yeah, I mean, this small hydro, you mean locally? I mean, it could be on-site or recently I visited a building which really has a small hydro on the building site, so you could take into consideration like PV on the roof. It also could be small hydro on your building site. Of course, this could be, but I guess that in Europe we have much less opportunities for using small hydro on site than PV, for example. But of course, we also could use small hydro on a larger scale, but I'm not really familiar with small hydro potential in other countries, but I'm familiar with small hydro potential in Germany, and it is said to be quite small, so the potential for increasing renewable energy generation from small hydro, so the role in these energy buildings would be small as well also in the future, because there is not too much potential. But it could be different in other European countries. Not aware of the small hydro potential in all of the EU member states at the moment.
Okay, thank you. So we have another question. I'm afraid we we will have to adjourn in a few minutes. We still have some questions. So how important is energy efficiency in terms of insulation, airtightness, in achieving the near zero energy building? Thank you.
Yeah. So it depends a bit on the climate region where you are in Germany. So for example, here within Ecofis, we have done calculations for all climate regions, not only in Europe, but also for the worldwide. And there are projects who've tried to do that. We also did it for a recent project for the European Commission, which was about defining benchmarks for energy, for nearly zero energy buildings. And as I pointed out, one of the major conclusions was really that it boils down to the two major principles, one of them being try to increase energy efficiency as much as possible, and obviously increasing the insulation level, improving the airtightness, elements of energy efficiency, and try to go as far as you can until the moment where it gets cheaper at the cost point to supply the rest with energy from renewable sources. So yes, insulation and airtightness are certainly in most of the areas in Europe major pillars to achieve nearly zero energy buildings.
Okay, thank you. So a question relative to primary energy factors used. Are you planning to use standardized factors for assessing the total energy demand of the whole supply chain, regardless the member countries, or is it going to be dependent on country by country basis? In that case, do you know how they are estimated, and have these primary energy factors been published already? On this point, I will submit a link to a report on primary energy factors, which is available on Leonardo Energy website. I will put it on the links in a few moments. But meanwhile, please, Andreas, you can go ahead.
Yeah. So the EPBD explicitly requires that primary energy factors should be determined country by country, taking into consideration the local situation. And so this is the first aspect in this. And so, of course, they vary. And in doing a life cycle balance, in fact, we have an additional question to answer, which is not at all covered in the current studies that we've seen, but we hope to get more grip on in the future, that when doing a life cycle balance, we do everything to try to cover the cost as good as possible, but especially in the case of electricity, we have just discussed that we assume primary energy factors for electricity dropping sharply in the future. So that means if you try to summarize the total primary energy consumption of a nearly zero energy building over its life cycle, somehow you have to take into consideration the projections about the drop of primary energy factors. Yeah, and we have some other very crucial questions which are very much simplified in the current discussion relative to primary energy. For example, making a difference between primary energy for imported and exported electricity. Yeah, I think you will see several publications about this topic in the future, and I think Hans put the link here, because recently we also did a study on primary energy factors and their variance throughout Europe, having a look at several countries. So Hans, I think you also could put this link, so then Eva could have a look at this and see how these primary energy factors vary between different countries we analyzed.
Okay, good, thank you. So the links are provided, so you will find on the right bottom window. So you just click on primary energy factors and then browse to. Okay, good. Maybe a few more questions and we will have to adjourn. Do you have still some time, Andreas?
Yes, I have. I'm happy to answer more questions on that, of course.
Okay. So
I know it was quite a comprehensive. I know it was quite a comprehensive presentation, so it's totally okay to have some questions afterwards.
Yeah. Okay. Excellent. So we're happy to have such a good speaker today, being able to answer so many questions in the audience about this topic. Excellent. Thank you. So different countries have different renewable energy availability and climate. Are there any EU-wide trials to identify the best and most cost-effective solutions for different locations? Thank you.
Yes, so there are. I mentioned a project that we just finalized. So we led a consortium, so Ecofis led a consortium together with Politecnico di Milano and University of Wuppertal. And we did a project that was called Towards Nearly Zero Energy Buildings for the European Commission. And this was really about trying to define and to calculate by quite heavy simulations benchmarks for near zero energy buildings for the different climate regions and also different costs, investment cost and operation cost regions that we have throughout Europe. And the final report is ready, but it hasn't been published yet by the European Commission. But this is really something that I would like to point you to. Please have an eye. Maybe we can also publish it the moment on Leonardo, the moment the European Commission has published this report, because it really exactly deals with this question. So which are the solutions for near zero energy buildings that should be applied in different regions in Europe?
Okay, thank you. Okay, so let's go for another question. One moment, please. Okay, so this question, I believe, is relative to the concept of balancing areas again. So I will just read it in case we have to add anything on this. I think energy management from small to large scales, buildings to cities, is absolutely important, and probably the cheapest and basic implementation in order to achieve near zero energy building or similar. What do you think about this? About this future development on near zero energy buildings and areas? Maybe we already commented before. If you think the topic is covered, we can skip to the next.
Yeah, I think it's a new question, in fact, but it's a really big question because Guillermo says from small to large scale, and this is really a big difference. So I think on a small scale, there have been quite a number of studies about the effect of building management systems, and the result was that the moment we have achieved something like passive house level, you still can save something between 10 and 20%, but in the case of a nearly zero energy building, you save 10 or 20% of something which is close to zero already, so the effect is quite small. But energy management systems make a lot of sense relative to the other electricity uses, I think, which have an overarching impact on cost and environment in the case of nearly zero energy buildings. So I think yes, for electricity and for all the other uses which are not covered by the EPBD, it makes a lot of sense in nearly zero energy buildings. Yeah, and on a larger scale, of course. But currently, as we have discussed, we really lack a definition of nearly zero energy buildings districts or areas or countries even. But in this context, obviously, when also thinking about the load shift potential of buildings and including electric cars, for example, in this case, energy management and setting up things like virtual power plants, energy managed systems are indispensable for managing this.
Okay, good. So just to close the session, a few quick questions. I think you already mentioned whether there are avenues for retrofitting existing buildings. Is this something that would be applied, or this directive should be applicable to big retrofitting projects, or not, or it doesn't apply at all for existing buildings?
Yeah, I mean, there is no mandate in the EPBDs directly as it is for new buildings, but what we have in the European Performance of Buildings Directive is that every 4 years, I think, every member state has to hand in a report about the number of nearly zero energy buildings, and this is not only about new buildings but also about renovation of buildings to nearly zero energy building standards. So every country has to provide a kind of roadmap on how to increase the number of nearly zero energy buildings also in the building stock. And at the same time, also the Energy Efficiency Directive requires roadmaps for the whole building stock, which in the end also means how to deal with increasing the number of nearly zero energy buildings in the building stock as well. As I have pointed out at the very start of the presentation, the whole building stock, so the buildings we have today, in principle also has to be very close to zero by 2050 if we really would like to reach the targets. And this is only 37 years from now. And when you take into consideration realistic renovation rates of maybe something like 2%, then you see that if we start now, we will just make it until 2050.
Okay, good, thank you. What can you tell about geothermal energy? It seems to be considered, but there a major role? Do you see? What can you comment on geothermal? Thank you.
Yeah, I think generally geothermal energy will have an increasing role in the overall energy system. So recently there has been a very big report by WWF which is called the Energy Report, where geothermal energy also plays a major role in the future energy system. And I think this will also be the case in buildings, maybe not on a single building level, but this is also something that will get more relevance in nearly zero energy building districts. So currently we are working, for example, in a district in Hamburg, in the city of Hamburg, and they also look at possibilities to use geothermal energy for a whole district in order to get closer to nearly zero energy building level there.
Okay, good, thank you. Okay, so let's go to the last question. Well, it's rather a comment, whether the human factor, habits, and so on can play a role here.
Yeah, that's a very, very good question. So I like this. Yeah, I mean, I think it's very important that this is something which really disturbs me a bit in the German regulation, that the calculation algorithms that we have for calculating the energy demand really use inputs that are a bit closer to the real behavior of the people. So currently we unfortunately have the case, for example, in Germany, that calculated values in low energy buildings are usually lower than what the monitoring shows afterwards, but the main reason for that is that simply the input values for the calculations do not reflect the reality. And I think that should be more in line, and then on average better or worse behavior in quotation marks should level out, and the average of this should be the same what has been calculated beforehand.
Great.
Of course we have differences in behavior, and it will lead to differences in energy consumption, but on average it should be nearly zero energy building level.
Excellent, thank you very much. Okay, good. So we have to adjourn now. So first of all, thank you very much, Andreas, for this interesting presentation, comprehensive Q&A session. And of course, thank you very much to our audience. You showed a keen interest for this topic, so let's consider upcoming sessions around this topic. Thank you very much for your questions, and then, well, looking forward to see you soon again in our webinar program. Don't forget to go through Leonardo Energy website, where additional publications are available on primary energy factors.